Howdy. So transformations of exponential functions. This topic you should be studying most likely in grade 11. Maybe possibly you may study it earlier. We'll see depending on which program you are taking. Now, exponential functions are super important. I will make the assumption that you're comfortable with at least the introduction to exponential functions already, because the transformations are kind of a step up. So if you like, you can watch the introduction to exponentials up above. I'll put up a link there. Now, if you're going to take transformations, you may recall in grade 11, initially you typically study transformations on some various parent functions. And some of those parent functions could be, for example, just a line. So for instance, if you take a line y is equal to x, which is just a straight line with slope 1 goes through 0, this is considered the parent function for lines. You may also have studied parent function, for example, quadratic, which is like this, and that is a parabola, so it goes along, and then of course you can transform that parabola in numerous ways for these particular quadratics, so it just starts to move it around, okay, or flips it up and down, and so on. So that's another one that you possibly have studied. You maybe have studied, the cubic function as well. So for this cubic function, which kind of looks like, that, more or less. All right, parabolas look like this, and of course our, beautiful lines, okay, that we study probably to death in high school, especially in the beginning. So kind of look like that. And you can continue with these parent functions. You maybe have studied, for instance, the square root of x, okay, which typically we take just the positive values, so it may look kind of like that. All right. You may have studied maybe the absolute value, which kind of looks, so the absolute value of this. So it looks like a line, except it has a kink, all right? So it kind of looks like that. And I'll put ... here, so it will just depend on what parent functions maybe you have studied. Now, we want to add to these parent functions, our function, which is the exponential function, and that's going to be some base b to the x, and that's what the introduction I was referring to that link, so you can please go ahead and watch it. So I do expect, so there's really kind of two cases, so it will depend if your base for your exponential is between 0 and 1, all right, so how that one looks like, which kind of flips downwards, or you have the case where b is greater than 1. The cases when b is equal to 0, or the case when b is equal to 1, again, I explained in that introduction video, so you can watch that. So I'm going to, for this video, just for the sake of explanation and talking about transformations, maybe I will just simply take this case and I will specifically, pick some value of b, whatever that might be. So maybe we can let b equal to 2 or 3 or 4. It doesn't really matter, as long as you understand how an exponential looks like. Now, for all of these parent functions, you have done transformations in grade 11. I have, in fact, actually done a video, and that's typically happens in the early stages of grade 11 when studying functions, for all of these parent functions. And what the nice thing is about transformations is they kind of go hand in hand no matter what the parent function actually is. So you can start manipulating all of these different functions and start moving them around, start stretching and compressing them in various numerous ways. So I will encourage you, if you've forgotten, you can watch the transformations on some of these parent functions. I have done that video for classes that are kind of a little bit starting off in grade 11. So I'll put up a link up above there. So that's transformations of these parent functions. And as just kind of a simple review, maybe I'll take one of these parent functions, let's say maybe like x to the cubed, and then I'm going to just do a little bit of a deja vu because it's going to lead to the same concepts for exponentials and transforming exponentials. So if I take, so I'm going to first, let's imagine, so this is not an exponential function, this is a cubic function, but let's say I take x cubed. Now for transformations, how they look like, so you can scale them in many ways so that it starts to compress or stretch in the y or in the x. And you can also transform, so you can translate, so you can move, okay, the functions around on your particular graph. And the transformations, that I talked about, you would take this function, so this f of x, and you would scale it up. So you multiply it by a, okay, so this is your function f, and then you change your input. So your input is not necessarily x, your input can change. So what I used to do is, I said, I had a b in here, so we would transform the input in this particular way. So x minus h, okay, so that is your new input right in here. So that's inside right there. And then you would also translate it, okay, by some k. Now, because for exponentials, we typically use b for the base, so I'm going to replace this, and so this b right here that you see here, because we don't want to have two b's for these transformations. So I'm going to remove this and I'll call it a d. So I apologize for that, but I just don't want to make you confused when I'm going to introduce this exponential right here just below it, so that you don't know which b I am talking about. So this is your regular transformations that you would have. And now these transformations, they do stretching, compressing, and then they do translating. Now I will add an additional item for us here, and that is that this a, they can be both positive or negative. Maybe let me do a different color so it stands out from the brown. So let's say maybe purple. So they can be positive or negative. And the same case, I'm going to shift this a little bit right here. Okay, let's move it a touch. Okay, in that way. And I'm going to move this over just so that it gives me space, because I also want to say that the d can be both positive and negative. Now, the h and the k, they can also be positive or negative, so that's fine, but I do want to stress these positives, okay? So maybe positive a and a positive d, and then a negative a and then a negative d, and I just want to remind you of what all of these things actually have done. So in terms of kind of a deja vu, I'm going to add a page here, and I'm going to steal, okay, this transformations, and I'm going to kind of duplicate it in here. Okay, let's bring it down a touch, and I want to talk about it just again to remind you what these transformations meant. All right, so what we mean with these transformations, let's do a little bit of a deja vu. So first of all, what you have is that I'm just going to concentrate on this a, and I just want to tell you, what happens to a. Well, if a is positive or negative, what will happen is that if it is positive, the parent function will stay as it is, but if it turns negative, then you will have a reflection, and this will be a reflection in the x-axis, which means that you're going to have a flip in the x-axis of whatever your parent function actually is. And your a, so the size of a, will actually create either a compression in the y, so it's either going to stretch it, okay, out, or compress it down. So compressing means it is, pulling it down in this direction, so it's trying to compress it down, or it will stretch, meaning it's going to try to pull apart the actual parent function. Let me show you that on Desmos. Here is x cubed, and again, so this is not exactly the exponential yet, but I just want to kind of do this so that you can see the stretching, compressing, and then we'll come back to do actually the exponentials as well in just a moment. So I'm kind of going to go back and forth. Now, in here, what I've done is I've just set a is equal to 1. Notice d is equal to 1, and h and k I just made 0. So I'm kind of returning back to my original parent function, so they're overlapping. And if I now change a, so notice it's positive, but now if I make it negative, okay, in this particular way. So let's say if I made it negative, what you've noticed is that it's been reflected, right? It's been reflected in the x-axis. So it just kind of flipped over from its original. So the red kind of just flipped over itself. That's what the negatives will do. So it's going to always flip over. Now, the other thing that I said is that if you take your A and now it will either, and if you make it bigger or smaller, it will start to compress, okay? So it's going to compress it down, or it's going to stretch out your actual parent function. So here, so if I do this, so notice, if I try to make A smaller, so it's between basically 0 and 1, you know, you may recall from those videos on transformations, notice that it's basically trying to compress this thing down. It's trying to push down, okay, everything and compress it. Now, if you make it more than 1, so if I kind of go back in here, so notice now it's trying to stretch it out. So it's trying to pull it apart. That's what actually the A does. Now, let us do exactly the same thing, because I want to just show you that it is identical when you start working, okay, with the exponential functions. So now for the exponential functions, I'm going to go back in here, I'm going to change my function. And, you know, let's say that we're going to work with 2 to the x. Now you can take 3 to the x. You can take anything to the x, okay, as long as it's positive in some way. So here I'm going to take 2 to the x like this. And now notice we're going to do the same thing. So what I'm going to do is, okay, so if I do, okay, and change this to negative, what we want to see is we want to be able to see a reflection in the x, and that's exactly what has just happened, right? It reflected it back. So that's exactly the same as for all your transformations of your parent functions, which is great because it doesn't make your exponential any different. So it shouldn't feel like it's something different. You're applying the same things, just your parent function has changed. Now, the other concept that we said, okay, so now is, you know, is it going to compress it down, or is it going to stretch it out? Okay, so if I make it bigger, it should start stretching it out, and indeed, it just kind of starts to pull it apart, okay, from what it originally is. So it's just starts pulling it, okay, in this direction. And now, if I make it kind of go in less than 1, notice it starts to basically start to compress these things down. So from its original, it just starts to move it down and keeps pushing it down. So that's what the A actually will do to any parent function, including the exponential. That's something that you see. And if I keep moving this around, notice when I switched it negative, indeed, it kind of did the reflection, and now it's going to start compressing and stretching depending on the magnitude of your A. Okay, so it starts to do that. And I encourage you, you know, load it up into decimals like I have. Play around with it so that you can see and get a feel for it, because it's great to be able to do that. So I'm going to return this back to 1. Okay, and I'm going to return this function back to x cubed, okay, within here. So now, what about next? So that's what A does. What does this D do? Okay, so what does this D do? Well, so for the D, again, if it's positive or negative, so this is again going to be some kind of a reflection. And you might guess, you know, if this reflected it back through the x, then this should reflect it back in the y-axis. So that's what this should actually reflect on. So if we graph it, okay, there should be a reflection, a mirror image, okay, for this. So let's see that happening in just a moment. Now, in general, for that D that I have in front, that D that you carry is again going to be compressing and stretching. So it's going to do this, okay? So this compression and stretching that I have, I'm going to replicate it. But in this particular case, this D, it doesn't do that in the Y, it does it in the X. Okay, so it starts to compress, or it's going to start to stretch it out in this direction. It's going to start to either pull it apart, okay, or it's going to start to bring it in this direction. That's what we should see through that D. So let's do that, okay, in decimals. So if I only work on D now, Okay, so notice I'm going to change this and I'm going to make it -1 and you'll see a reflection. Notice in the y, right? So it reflects it back in the y. That's what it does. It just flips it over. Okay, so that's what has happened in here. And now if I go back in here and I start playing around with it, notice it's going to start to compress and stretch. So now when it is, getting bigger and bigger, okay, it starts to bring it in this direction. Okay, it's almost like the same thing as if it's being kind of stretched out in this direction in the y in some particular way. So it's bringing it in this direction. Okay, so it is compressing it, okay, in this direction. Now if I make it smaller than 1, okay, notice that what it starts to do is it starts to basically stretch it out in the x direction. So it takes the function, the red one, and it starts to pull it, okay, like this, and starts to stretch it out. All right, so that's what happens, and that's what the d does. And of course, you can kind of go back between negatives and positives, okay, and you'll see that happening. Now, is that the same thing that happens to our exponential? Well, let's take a look. So if I take an exponential, so let's say 2 to the x, again, it doesn't matter what you have. So if you take it, it can be 3 to the x, whatever it might be. Now we want to see the same thing. So let's say if I put d, okay, and I put negative, and notice what happens. There is basically a reflection in the y, so it just reflects it back. And again, if I now start playing around with it, so notice what happens in here. Now it's bigger because it starts to compress it. It starts to squeeze it into this direction. And now, so if I keep going, just keeps squeezing and squeezing and squeezing. Now on the other side, if it's between 0 and 1, notice that it starts to stretch out in the x in this direction, tries to pull it apart. So that's what the d does. And that's the beauty, that if you understand transformations for one, and now you start doing them, they should become repetitive. Doesn't matter if it's exponential or not. Now, the last two items, so these ones right here, so our h, so minus h, and then this k. So what do these, what do they have to do, okay, or what happens to them? Well, the h is actually going to be translating, so it's going to be moving, so it's translating the actual parent function, okay, in the x direction. And the k is going to be actually translating it in the y direction, so moving it up or down. So here it's going to, in the x, it's either going to move it in this or this, okay, and in the y it's going to just shift it. It doesn't do any compressions or stretches, it just moves things around. So let's take a look on decimals, and I'm going to come back here to the x, cubed, okay, within here, and I'm going to, make the d1, and now I just want to show you. So here's your h, so I'm going to go back to h, and notice all it's doing is it's moving it left and right. That's all that it will do. That's your actual h, shifts it back and forth, okay, so that's what happens there. Now what about your k? The same thing, except now up and down. So it starts to move it kind of up and down. So here, let me zero off the h so you can actually see it directly, okay, so that it's all that it's doing is just moving it up or down, up or down. That's all that happens. Now, what if, let me set it back to 0, what if I had an exponential of some kind? Okay, so now let's see if it's going to be moving it up or down, okay, if I take the h, okay? So here, now this is much harder to see because the exponential only has it in one direction, all right? But what you're doing is you're just shifting it, okay? So I've just shifted it by 2.7, so it's moved over. So, if you look at these plots that I have in here, okay? So in terms of here, let me say that I want to move it by 2, okay? So if I move it by 2, let me plot here. So this original one, I'm going to say, 0, 1, okay? I'm going to plot it up just so that you see that point, and it's just got shifted over. And now I'm going to, so since we moved it by 2, so it's going to be 2, 1, okay? Because I moved it in the x by 2. Let me label them. And notice that was h2, so just shifted it over, all right? And if I made h negative, it would have shifted it over in the opposite direction. So that's what happens. Now, what about, so if I set this back to 0, what about k? It should move it up or down. So that's what we want to see. So notice, okay, up or down in this direction, up or down. And here, moving the up or down also changes the asymptote, because our exponential has an asymptote at 0, right? It has a flat line. It doesn't go further, it just approaches it. And if you're going to be moving this k, you're also moving the actual asymptote. So if I move my k, let's say to 2, okay, like this. Let me close this one off so that we don't see it. Okay, so if I move this by 2, you've just moved the asymptote by 2. Which means you've actually changed your range on this actual exponential. So your range is now changed because it's going to be everything above 2. And that's what we have there. And now we can start bringing all of these things together, right? Where you're not just playing around with one of the variables, you're playing around with a, d, h, and k, and you start thinking about, okay, so what do these things actually do? All right, so that's what you have in terms of all of these transformations. And what I'm going to do is, I guess I'll set up another video which I'll give you a few examples of for you to think about, and try to think about the graphing on its own. Maybe when that video is up, I'll put up a link up above there, and I'm going to show you through some examples exactly these concepts, but with actual exponentials. So this is hopefully, an introduction, a rather long one, but it brings you back to these transformations. So remember, the reflections, the compressions, sketch the actual stretches, and then the translations, depending on what happens. Okay, thanks for watching. We'll see you in a future video. Bye.